Woohoo! Welcome back. Today we're going to be talking a little bit more about 1.6, and what we're going to be working with is the algebra of supply and demand. Specifically, if we are given a demand curve and a supply curve, can we find the market equilibrium? And the answer is, of course we can. Of course we can. So let's go ahead and take a look. So I've got my demand curve, and it is offered to me in this really interesting way where it has been, and in order to not confuse things, let me not use an equal sign there. What I'll use is a little colon. That'll make it easier. So we've solved for P. We've got P equals, which is really interesting. Remember that P represents price. And then we've also got a supply curve, which looks like P minus 17Q equals 80. Now, if I want to find the market equilibrium, basically what I'm looking for mathematically is a point that satisfies both equations. We're looking for a price and a quantity, or a quantity and a price. And what's really great is that we already have ways of doing this. We know how to solve a simultaneous set of equations. So in this case, if I've got two equations, I can use either elimination or substitution. I'm going to use substitution. So I'm going to take P minus 17Q equals 80, and in place of P, I'm going to put, you know what, I'm going to use green. In place of P, I'm going to put the demand equation in place of P. So up here, the demand says price would always be equal to this. So I'm going to take this equivalent for P and put it in place of P in the supply side equation. So this is supply. So we're sneaking demand and sticking it inside the supply. And now we've got an equation that we can solve for Q. Woohoo! So how do we do that? Well, we take 480 minus 3Q and subtract 17Q. And then I can combine these two because they're both in Q, so they're like terms. 480 minus 20Q equals 80. And again, we've got that ugly situation where there really aren't any good solutions. Sorry about that, Sharktopus and Godzilla. I got excited. I'm going to go ahead and subtract 480 from both sides. Feel free to do it a different way if you would like. I get negative 20Q equals negative 400. And then I divide by negative 20. So that I get negative 20Q over negative 20 equals negative 400 all over negative 20, or Q equals 20. Ooh! So my equilibrium solution quantity will be 20. So whatever these things are, in the perfect world, we would sell 20 of these. Now, I need to, because this is a system of equations, and each equation has two variables, not just Q, but also P. I have to find P. But I have an equation, the demand equation, that came out of the green one. It's 480 minus 3Q. So I plug in the Q, which is 20, and what I'm going to do is very quickly, just to help you remember, this came from the green. This is the demand equation from up here. We plug the Q into that, and we get 480 minus 60, which is 420. So our quantity, our equilibrium point is going to be quantity equals 20 and price equals 420. Now, if you're saying to yourself, wait a minute, that seems awfully easy. How do you know you didn't make a mistake? And the answer is, well, I don't ever know if I don't make a mistake, but I can check it. So how do I check a system of equations? Well, in reality, you're supposed to check both equations. But in reality, multiple realities, I just solved for P here. This is the demand equation right here. I used it. So I'm not going to check that one again, but I am going to check supply. So let's check the supply equation that says, P minus 17Q equals 80. Okay, and my quantity was, how many are we selling? We're selling 20 for 420 each. My price is 420. So let's check. 420 minus 17 times 20. Is that equal to 80? Let's check. 420 minus 17 times 2 is 34. So 17 times 20 is 340. No shame in checking that on a calculator. Definitely use your calculator in times like these, especially if you know that your brain has a habit of, moving numbers around and stuff. 420 minus 340. Again, go ahead and check this on a calculator, but I do believe this is 80. Woohoo, we checked it. Nice work, nice work. Okay, so that's the equilibrium point for this particular supply and demand. Next question. What if the supply and demand is not that simple? And in fact, I've given you even an extra wrinkle. And the extra wrinkle is Q is in the hundreds. Oh my goodness. What are we even going to do? And the answer is not panic. We're going to see this and we're going to go, oh, I've got a demand equation that looks like 3P plus 5Q equals 15. And a supply that looks like 4P minus 3Q equals 2.6. Oh, yay, decimals. Just when you needed them. So if I look at these, I'm going to say substitution is going to be really hard. I would not recommend substitution. What in fact we probably want to do is use the other one, which is called elimination. So let's use elimination. So this is the one where we line these up. We make sure the P's and Q's, mind your P's and Q's. That's not what this means, but you know what I'm saying. So line up the P's and line up the Q's and line up the equals and the numbers. So everybody is in line. And then what we try to do is we try to cancel somebody. Now, I could cancel the 3P and the 4P, but they're both positive, which means there'd be a lot of work involved. In fact, I've got the 5Q and the minus 3Q. They're opposites already. So what I want to do is I'm going to go ahead and eliminate the Q's. So how am I going to do that? I'm going to multiply on top by 3 and on the bottom by 5. And remember what we do is we multiply the whole equation. So 3 times 3P, 9P. 3 times 5Q, 15Q. Equals 3 times 15 is 45. Make sure you multiply every single term. Otherwise, you're going to be in a whole world of hurt. 5. Let's go ahead and multiply everybody by 5. 5 times 4P is 20P. 5 times negative 3Q is negative 15Q. And 5 times 2.6 happens to be, it's not quite 15, it's 13, right? I think. Let's hope so. In the next step, we add. Now, in a perfect world, if we did this correctly, the way elimination works is you set it up so that when you add, the Q disappears or is eliminated, right? So if we do that correctly, the Q's cancel out. And all we have left is 9P plus 20P, so that's 29P equals 45 plus 13 is 58, which looks horrible, but it turns out that P is divisible by 29. It's just 2. So P is, and we assume P is in dollars. We aren't given much more information. So now we need to find, come over here, now find Q. Okay, so for Q, I can pick either equation. I'm just going to go ahead and pick the demand equation. 3P plus 5Q equals 15. If P is 2, then I've got 3 times 2 plus 5Q equals 15. Okay, so 6 plus 5Q equals 15. Subtract 6, subtract 6. 5Q equals 9, which is weird. 5Q is 9. 5Q over 5 equals 9 over 5. So Q is 9 over 5. And hopefully you know this trick, but in case you don't, whenever you've got a fraction that's being fractiony at you, you can always do division, right? So I do 9 divided by 5, and that gives me 1.8. Okay, so what the heck? And then I come up here and I go, oh, Q is given in hundreds. So my equilibrium point is going to be my price is $2, and my quantity is 1.8 in hundreds, so it's 180. If that makes sense, because Q is 1.8. Now, if we want to check it, again, I used the demand to find Q, so I'm going to check with the other one. I'm going to check with supply. So supply is 4P minus 3Q equals 2.6. So I've got 4 times 2 minus 3. Now, don't put 180 in, right? Q is actually 1.8. 1.8. Does that equal 2.6? Let's see. 8 minus 3 times 1.8 equals 5.4. 5.4 equals 8 minus 5.4 equals 2.6. Yay! And I checked it. Yay! Now, for a problem like this, keep in mind there are 2 possible answers that that WebAssign might ask for. It's possible that when you're looking at Q, if it asks you what is Q, the answer is 1.8. If they say what's the quantity, it's 180. So slightly different answers because the variable is given in hundreds, if that makes sense. Okay, so you guys are doing awesome. Those were the 2 examples like that. Now for this one, we're going to do something a little bit different. And this is because I realized in teaching this that a lot of people don't recognize something that is going on right now. So if our demand function, our demand curve is given by P equals 480 minus 3Q, that tells us our price is equal to 480 minus 3Q. Now, this is a very particular situation, supply and demand curves, and they are done in a very traditional way with P and Q. But in fact, Q represents quantity, which means that Q is just X. So in our setting, when we're talking about revenue and cost and profit, our X is just the quantity. And so our demand curve, our demand equation, P equals 480 minus 3Q, gives us price equals 480 minus 3X. So what is the revenue? Revenue, which is R of X, remember, is the price times the quantity. And you know the price. It's 480 minus 3X. All right, this is the price. My favorite price is Vincent Price. Okay, so we've got the price times x. So this is the price from here. So I multiply, I get 480x minus 3x squared. Now this is foreshadowing because right now we're in chapter 1, and in chapter 1 everything is a straight line. But oh my goodness, dun dun dun! In the last problem we're doing for chapter 1, suddenly we get an x squared. And x squareds are parabolas. Dun dun dun! Which is foreshadowing for chapter 2. Because chapter 2 is going to be all about parabolas. And in case you don't remember, parabolas are the ones that look like this. This one happens to be a frowny face, right? If you draw the imaginary eyes there, it's a frowny face, but they're also happy faces too. So at the end of this chapter, what we're doing is we're saying goodbye to lines and we're moving into parabolas, which is going to be great because honestly, most humans do not move or think or act in a straight line. We're much more likely to look like, kind of lumpy, bumpy decision makers like that. So, nicely done. You guys made it through chapter 1. Woohoo! So, go give yourself a break. Go give yourself, some happy joy time. Get yourself some hydration, some vegetables, some exercise, some art, some music, maybe some napping. Maybe go watch an old horror movie if you like them, or go watch another movie. And then I'll see you again in chapter 2. Woohoo! And math on. You guys are awesome.